In a similar way to second order parametric differentiation, second order implicit differentiation is relatively simple, provided you know how to do it once. You start with an implicit function, you implicitly differentiate it, and then you do it again. And as always, there's nothing like seeing an example for you to get the handle of it, and then it's all about practicing. On section 6.6, you'll find an implicit function that we're going to try to second order differentiate. How do we obtain second order implicit differentiation of this function? Step number 1 is to find the first derivative. If you remember how to do it, it's all about applying derivative operator to both sides. This side is even easier. But let's do it properly. What we want to do is to apply d dx to both sides. That's to y squared minus xy. And then d dx of 8. We get 2y dy dx minus, in this case, we're going to use the product rule, the derivative of this. So we're going to have y minus x multiplied by dy dx. And in this case, if it is not clear yet, y is assumed to be a function of x. And therefore, every time we differentiate a term that contains a y, we need to use chain rule. And on this side, we get 0. Once you get to this step, you should now be really familiar with how to do this. We group the terms, which means we can then write dy dx. We take y to the other side. It becomes plus because it's negative here. And then we're dividing by 2y minus x. If we just wanted to do first order implicit differentiation, this would be the answer. How do you go about getting the second order implicit derivative? In the same way, essentially you apply the operators to both sides. This will give you directly, essentially, you'll get the second order derivative. And on this side, when you apply d dx, you will need to use the quotient rule. Essentially, it means you need to multiply as 2y minus x times the derivative of y, not forgetting chain rule, so this means it's 1 times dy dx. And let's move this expression to the right. It's much better, so we actually have space to write the other term of the quotient rule, which is minus, and now we're multiplying y by the derivative of 2y minus x. Because there's a 2y, this becomes 2 dy dx, and for minus x, it's just minus 1. And at the bottom, we get 2y minus x squared. The typical final step in second order implicit differentiation is to realize that we already know what these terms are because we have calculated them. And therefore, it's all about just subbing these things in. If we do that, this becomes 2y minus x times, and there's a y, 2y minus dx, so I'll put it here. It means this term will cancel, and on this side we have y 2y over 2y minus x minus 1, and we're dividing everything by 2y minus x squared. When we get to this stage, this is when the board starts to be a problem, so we need to clear it. We now have space, and what we can try to do is get everything on the top to the same denominator. in this case 2y minus x. Let's try to do it. In this case, we end up with 2y minus x times y over 2y minus x minus 2y squared divided by 2y minus x minus, and this is being multiplied by y, which means we get 2y squared minus xy over 2y minus x. And because we're dividing everything by 2y minus x squared, this is the same thing as multiplying by 1 over 2y minus x to the power of 2. So we'll see that we can write this as something divided by 2y minus x to the power of 3. And on top, we can have a look at what we have. We have 2y squared minus xy minus 2y squared minus 2y squared minus xy. This means these terms will cut, and we end up with minus 2xy minus 2y squared, which is a point that you probably realize once you go back that there is a sign that has been wrongly placed, because this is minus minus, this term has a plus, and therefore this is incorrect. We actually have a plus here, which means this is minus 2xy plus 2y squared, which will be hopefully our final result, which is minus 2xy plus 2y squared. And for second order implicit differentiation, this would be your final answer. And I can even argue that I've made a mistake on purpose just to point out how easy it is to make them, especially when you have a lot of terms, and specifically for minus signs and forgetting them. So always try to look back, check your steps, and if you find anything that's wrong, make sure you fix it and then propagate it. The other thing that I would encourage you is, especially for worksheets and for practicing, check the final answer on something like Wolfram Alpha or any software, so you know what you're working towards. And if it looks very different, really double check all your steps and you'll probably find where the mistake is. I think this is a very good tip that you should take on board.